Hi, my fourth graders, welcome back. This is lesson 6.3 Relate Factors and Multiples. Our target is to understand the relationship between factors and multiples. Now, we are going to take a look whether a number is a multiple of another number and whether a number is a factor of another number. You see that? Multiples and factor. What's the difference, right? And I can explain the relationship between factors and multiples. Um, Today's lesson, 6.3 yesterday, I was talking about what? The relationship between multiples and factors. Do you remember? In the multiplication chart, for example, 3, 6, 9, 12, 15 is multiples of 3, right? And let's see here, 2, 4, 6, 8, 10. So the sixth one, like here, 6 here. 6 is a multiple. 6 is a product of two factors, which is 2 times 3. And multiples of 2's are 2, 4, 6, 8, 10. Continue. And multiples of 3's are 3, 6, 9, 12, 15. Continue. You see the difference? So factors are the numbers, two numbers that when you multiply by together, and then you are going to get the factor or the given number in this factoring, right? And then the multiples of the number is what? Yes, you need to skip count by the number. Okay, skip count by 2's, skip count by 3's or 4's, 5's. Okay. And now, next criteria is what? I can explain the relationship between factors and multiples. Okay, they're related but not exactly same. So we are going to take a look at that together. Okay, now list all factors of 24. Now let's go ahead. We can find 1 times 24. And what did I say? When you work with this factoring, you have to consider two things first. When you see the number, you have to see that number is even number or odd number. Okay, and then sum of two numbers. Okay, two digits, which is what? 2 plus 4, 6. 6 is what? Multiple of 3. That means what? This 24 is, yes, 24 is divisible by 3. Okay, so of course this 24 is even number. So we can divide this, what? 2. Yes. So 2 times 12 is 24. Right? What else? 3. Yes. Since the sum of two digits is what? 6, which is multiples of 6. Okay? Multiples of 3, sorry. That means what? This is divisible by 3 as well. So 3 times what makes 24? Yes. 8. Okay? 3 times 8 makes 24. And what else? Yes, this is divisible by 6 as well, since this is multiples of 3 and even number. Okay, it can be 4. Oh, no. So 4 is also, right? So 4 times 6. Yes, sorry. 6 times 4 is what? And 4 times 6 is also 24. All right. And what else? 5 is not possible. 6 is here already. So we just learned it yesterday that we don't have to go over than this 6. Okay. Since the number is going to be repeating. Okay. So now all the list of factors. Let's do it again. 1, 2, 3, 4, 6, 8, 12, and 24. Now, they're asking us to list several multiples of each factor. So multiples of each factor. So we have how many factors here? 1, 2, 3, 4, 5, 6, 7, 8 factors, right? And we need to list the several multiples of each factor. So I'm going to list them, and they were asking what number appears in each list. Okay, let's take a look. 1, we have 1 factors are 1, 2, 3, 4, 6, 8, 12, 24. So now I'm going to write down the multiples of each factor. Multiple of 1 is what? Yep, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Multiples of 2. Okay, 2, 4, 6, 8, 10, and 12, 14, 16, 18, 20, 22, 24. Okay, 21. Okay, let's go up to 24. 22, 23, and 24. Okay, and then multiples of 3. 3, 6, 9, 12, 15, 18, 21, 24. Okay, multiples of 4. 4, 8, 12, 16, 20, 24. Multiples of 6. 6, 12, 18, 24. Multiples of 8. 8, 16, 24. Multiples of 12. 12 and 24. Okay, so I want you to take a look. And what number appears in each list? We'll see. Here, of course, this is 24. And this one has 24, 24, 24, 24, 24, 24, and 24. Okay, so 24 appears in each list. Okay, and now let's move on. Number sense, guys. How are factors and multiples related? So factors are what? Factors are 1, 2, 3, 4, 6, 8, 12, 24. They are factors. And multiples of are what? Multiples are 1, 2, 3, 4, 5, 6, 7, 8. Okay, multiples of 1, multiples of 2, multiples of 3, multiples of 4, multiples of 6, multiples of 8, and multiples of 12 and 24. How they are related? Okay, each factor has, let's see that, each factor has what? A multiple equal to the number, which is 24, original number is which is being factored. Okay, this 24 was factored, right? We did just factoring of 24 and we found out the factors, right? So which means what? Each factors, okay, each factor has the multiple, okay, of the number was the original number was being factored. Okay, so I'm gonna make it clear here. I'm gonna write it down. Maybe you get confused what I mean. If you don't get it, please rewind and try to listen again. Okay, but I'm gonna write it down in here. So each factor has a multiple equal to the original number here, which is what? 24. Okay, number being factored. Okay, so we factored what? 24. We found out the factors of 24, right? So each factor, which is 1, 2, 3, 4, 6, 8, 12, has a multiple, right? When we found out the multiples of each factor, we have what? The original number, which is 24. That's what it meant. Okay, so original number being factored, which means what? We get the original number, which is 24. On yesterday, we were talking about what? Given number. Okay, they are same. All right, so you see the relationship? Yes, factor and multiple. Okay, so they are related, but it's not same. Now let's move on and we are going to take a look more about this relationship. Okay, so a whole number is a multiple of each of its factors. So 12 is a multiple of 1, 2, 3, 4, 6, and 12. Okay, so look at this. 1 times 12 is what? 12, of course. And then they are what? Factors. Okay, factor pairs here. Now, that means what? You don't have any remainder. Okay, when you divide this 12 into by 2 or 6, you are not going to have any what? Remainder. Okay, that's the whole number. Okay, the whole number is a multiple of each of its factors. Okay, all right, so now example. Is 56 a multiple of 7? That means what? Is 56 can be divided by 7 or not? Okay, we are going to take a look. All right, so look at this, guys. List multiples of 7. Since we just did it, right? So when you list the multiples of this factor, this 56 has to be in, yes, multiples of 7. Okay, otherwise this 7 is not a factor of 56. Okay, so 56 is a multiple of 7, which is another way of saying is what? Is 56 is divisible by 7. Okay, or divide by 7. Okay, that's equal. All right, so now list multiples of 7. 7, 14, 21, and 28, and 35, and then 42. Oh, I said 42, but I wrote 49. Sorry. Okay, 42, 49. I was thinking ahead. Okay, 56. So 56, look at that. So 56 is a multiple of 7. Okay, which means what? You can divide this 56 by 7 and you don't have any remainder. Correct. Very good. So another way, use division. Okay, division skill we know already to determine whether 7 is a factor of 56. So 56 divided by 7, which means what? 7 times what? It's gonna make 56. So let's go ahead. 56 divided by 7. We don't have to do this, but still, okay? And since we know 7 times, yes, 7 times 8 is what? 56. Take away, nothing left over, okay? So that's 8. So 7 is a factor of 56. So 56 is what? Yes, is a multiple of 7. All right, now an example. Is 9 a factor of 64? You see the different question? Is 56 a multiple of 7? Is 9 a factor of 64? You see that? Multiple here, factor here. I want you to take a look. 7 times one number is gonna make 56. We practiced yesterday, right? And which is what? These are two factors. And this is what? This 56 can be the product, right? In the times table. And here, 9, okay? Multiples of 9 is 64 or not? Okay, that's the question. Is 64 a multiple of 9? That's the same question. Okay, so when you take a look at the times table, we know 9 times 7 is 63. That means what? This won't. Okay, this can't be. 64 can't be the fact. 9 is not a factor of 64. Or in the other word is what? Yes, 9. Okay, 64 is not a multiple of 60. 64 is not a multiple of 9. Okay, that's the same word. Okay, same meaning I meant. Okay, so here, guys. Now, also we know divisibility rule of 9, which is what? Sum of 2 digits has to be multiples of 9, which is here 10, so it's not. Okay, so 9 is not a factor of 64 because 6 plus 4, 2 digits, right? When you add, okay, so sum of 2 digits is what? Is 10, which is not a multiple of 9. Okay, so this is not divisible. So 10 is not divisible by 9. Another way, list multiples of 9, and this is the easy peasy one since we know the rule, right? 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay, here and then 1, 2, 3, 4, 5, 6, 7, 8, but we don't need to go up there because 64 is already here, right? We passed it already. So 64 is not a multiple of 9. So 9 is not a factor of 64. This sentence is really important. 2 sentences, okay? I want you to take a look and think what they're talking about. Okay, so we are talking about the product and factors in the times table. Okay, product and the factors. I mean, the two numbers. Okay, so when you multiply two numbers, you get the product. Okay, the product will be the multiple of one of the factors. Make sense? Yes. All right, let's move on, guys. Show and grow. Okay, is 23 a multiple of 3? That means what? In the multiple, like in the times table of 3 times table, do you have 23 or not? That's the question. Is there? No. We know. First of all, this can't be because, we know 2 plus 3 is 5. It's not multiple of 6. So 23 cannot be divided by 3 without any remainder, right? That we know. But let's go ahead. We can list. Do we need to? Okay, let's go. All right, so 3, 6, 9, 12, 15, 18, 21, and 24, dot, dot, dot. But we already passed 23, so we don't have to write down more than that. So the answer is what? No. How can you explain? This is the explanation. The multiples of 3's are what? 3, 6, 9, 12, 15, 18, 21, 24. 23 is not in there. So 23 is not a multiple of 3. Now let's move on to number 2. Once you understood previous 2 pages, everything else is really easy for you. Okay, so if you didn't get it, please rewind the video and watch it over and try to figure it out. Okay, math is always figurable. Okay. Still, if you don't get it, yeah, when I go over it during the class time, you can always ask me. Okay. All right, and is 8 a factor? You see that what they're asking here? They were using multiple. Now they're using what? Factor of 56. This is same as what? In the multiples of 8, 56 is there or not? That's the question. Okay, so we'll see. And also another word is what? Is 56 divisible by 8? We'll see. All right, so list the multiples of 3, which is what? 8, 16, 24, 32, 40, 48, and 56. Ooh, we can stop in here. So 56 is one of them. Yeah, multiples of 8. That means what? 8 is a factor of 56. Okay? All right, so the answer is what? Yes. Okay, so now let's move on. I want you to pause, and then if you didn't understand, please rewind and watch it over. Okay? That's not time consuming. You need to have that time if you don't get it. Okay? And then try to figure it out. Listen to my explanation, and if you don't get it still, try to think what he meant. And then still, if you don't get it, please put star mark on it as always, I ask. And then I'm going over with you guys, okay? After third graders is done. All right, so now number 3. Is 65 a multiple of 5? Which means what? Is 65 divisible by 5? That's the question. Yes, we know divisibility rule, right? Which is what? Any last digit ending with 0 or 5, that's divisible by 5, right? That means what? This 65 is a multiple of 5. So the answer is what? Yes. And then how to explain? I just explained, right? So last digit. So the ones digit is what? 5. Should I write it? Yes. Okay. Okay. Now number 4. Is 14 a multiple of 4? Explain. We'll see if that 14 can be divided by 4 without any remainder. So let's go ahead. 14 divided by 4. So 4 can fit into 14 by 3. Okay, and 2 left behind, which is what? Remainder. Okay, so what? Yes, 4 cannot be a factor of 14, right? Since there is what? There is a remainder. So the answer is what? No. We can show them this. 14 divided by 4 is 3, remainder 2, which is what? We can have. The factor cannot have any remainder, okay? Number 5, is 23 a multiple of 2? Heck no. Oh, I'm sorry, I cannot use that word. But you know, to make it clear, okay, so nah, why not? This 23 is not even a even number, okay, so the answer is no. We don't have to do anything else. 23 is not even. Okay, number 6, is 6 a factor of 96? We'll see. First of all, what did I say? The divisibility rule of 6 is what? Okay, multiples of 3, and if the number is, yes, even number. So let's add them together. 9 plus 6 is what? 15. And 15 is what? Yes, multiple of 3. So that means what? Yes. Okay, so you can say 96 is even, and sum of 2 digits is what? Is 15. Okay, which is multiple of 3. Okay, can you still see this? Yes. All right. Now number 7, is 3 a factor of 82? Explain. Okay, so to be a factor, it has to be divisible, right, by the factor, and doesn't have what? Any remainder. To know that, we know what? The rule of divisibility. That means what? When you add these 2 digits, okay, sum of 2 digits is multiple of 3 or not. That's it, right? So that's 10, which is what? No. So the sum, let's say this 8 plus 2 is 10, and 10 is not. Okay, I'm gonna put it again. 10 is not divisible by 3. Okay, and number 8, is 9 a factor of 72? We'll see. So divisibility rule of 9 is what? Sum of 2 digits, which is here 9, is multiple of 9? Yes. So the answer is yes. 7 plus 2 is 9, which is what? Multiple of? Not multiple, sorry. Divisible by 9. Divisible by 9, okay? Tell whether 8 is a multiple or a factor of the number. Right, multiple, factor, or both. Okay, tell whether 8, okay? This is the number that we are working on. Compare, okay? So the number 8 is multiple of 4 or factor of 4, or what is it? Both. So 8 is what? Yeah, multiple of 4. And 8 is what? Okay, it can be divided by 8, which means what? It can be multiple. 8 times 1 is 8. And yeah, 1 times 8 is what? Also 8. So this can be both. It can be multiple or factor. What about 32? Is 8 multiple of 32? Doesn't make sense at all, right? So multiples of 32 can be only what? 64, 96, blah blah blah. Okay, and then factor, we'll see. So this can be divided by 8. Let's check the multiple of 8. Yes, 8 times 4 is making what? 32, which means what? Yes, this is a factor. Now use the numbers 6 and 12 to explain how factors and multiples are related. Okay, so 6 and 12. So 12 is a multiple of 6, and then 6 is what? The factor of 12. That's we know. Okay, so we'll see. 6 is a factor of 12, and 12 is a multiple of 6. Make sense? All right. Number 13. Already 25 minutes past. Wow. It's a lot of writing, right? And explanation. All right, so complete the Venn diagram. Okay, so factors of 40. Okay, so let's find out. Let's do the factoring. I like that one. 1 times 40 is what? 40. I forgot to tell you. What are two things that you have to do before you start the factoring? Yes, you have to check if that is even number or odd number, and then sum of the digits, okay, which is here 4, which means what? This cannot be multiples of 3, 6, or 9, right? Okay, keep that in your mind and let's move on. And then this is divisible by 2 by what? 2 times 20 is 40. And we just said what? 3 cannot be the factor, right? And 40 cannot be divided by 3. What about 4? Yes, 4 times 10 is 40. And what about 5? Yes, 5, since this is ending with 0, right? So 5 times 8 is 40. Okay, what about 6? 6 can't be. What about 7? No. That means what? 8 again. Yes, and the number will be repeating again. So you don't have to find out anything else. And first 10 multiples of 5. We know 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. Now, since Venn diagram, you have to find out the common factor in this overlapping place, okay? And then write it down, the rest of them, about these first 10 multiples of 5 and factors of 40, put in here, each side, okay? So now let's find out the common number. I see 5, 10, and 20, and 40. Okay, that's it. So write it down. 5, 10, 20, 40. Which means what? They have both, like either side, they have both 5, 10, 20, 40, right? And write it down rest of them. I'm going to start from the factors of 40, which is 1, 2, 4, and 8. Okay? And then I'm going to write down here the first 10 multiples of 5, which is not belong to this. Oh, what happened? Oh, it just disappeared. Sometimes it happens like that. I don't understand. Okay, but anyway, we were doing what? 5, 10, 20, 40. Remember? Okay, and then it was 1, 2, 4, 8. Yeah, for video you can move or you can rewind, okay, and then watch it again. And the first 10 multiples of 5, which is not belonging to here in the both side, which is 15, 25, 30, 45, 35 first, right? 35, 45, and then 50. All right. Okay, let's move on to our last page. Excuse me. Okay. Unit 96 balloons for a school dance. Balloons come in packs of 4, packs of 6, and packs of 9. I just circled the number that we are working on. Which packs could you buy so you have no leftover balloons? Now use division to determine whether 96 is a multiple of 4. Okay, so you are going to know if you buy the 4 packs of balloons if there is no remainders, or 6 or 9. Okay, and to know that, what did I say? Check two things first. Okay, for the divisibility, which means to find the factor. Okay, so you need to see if the number is even or odd, and then add them together and see it can be divisible by 3 or 9, okay, or even 6. So here 9 plus 6 is what? Yes, 15, which is what? Multiple of 3, and this is even number. So at least you know what? 3 or 6. This is divisible by 6 or 3, okay? Keep that in mind, and we are going to move on. Okay, use division to determine whether 96 is a multiple of 4. Yes, so now here, let's do it. 4 can fit into 9 by 2, which is 8. Take away, bring it down, 6, okay. 4 times 4 is 16, nothing left behind. So, yes, so 4 is a factor of 96. And 96 is a multiple of 4. Because when you multiply 4 times 24, you are going to get 96. That's why 96 is a multiple of 4. Understand? All right. Use the divisibility rules to check whether 96 is a multiple of 6. We just did it already here. Okay, this is the 96 even number, and sum of 2 digit is 15, which is multiple of 3. That's the rule for the divisibility rule of 6. Okay, so 96 is even. Oh, that's what they just say. And then 9 plus 6, which is the sum of 2 digits, is 15, which is what? Yes, divided by 3. It's divisible by 3. So 15 is divisible by 3. So 6 is a factor of 96. And 96 is a multiple of 6. Now use the divisibility rules to check whether 96 is a multiple of 9. But we just did it. 9 plus 6 is what? 15. 15 is not a multiple of 9. Okay, so 9 plus 6 is 15 is not divisible by 9. So 9 is not a factor of 96, and 96 is not a multiple of 9. So you could buy packs of what? Yes, 6 and 4. So 4 balloons or packs of 6 balloons. Okay? Now last 3 questions, guys, and the time is already 31 minutes. Let's do it quickly. A teacher needs 88 batteries for science experiments. Batteries are sold in packs of 2, packs of 6, packs of 2, packs of 6, and packs of 8. Which packs could the teacher buy so she has no leftover batteries? Okay, so we need to find out what? The factors. Okay, if the 2, 6, 8 are factors of 88 or not. Okay, that's what we are going to find. So now let's check the divisibility rule. Of course, 2 is possible since this 88 is what? Even numbers. Okay, so 2 is possible first. What about 6? Yes, let's add these 2 numbers together, which is what? 16. And is this number, okay, at least this is even number. Okay, so, okay, let's check now if the sum of 2 digits is the multiples of 3. No, 16 is not a multiple of 3. That means what? It's not divisible by 6. What about 8? Yes, we know 8 times 11 is what? 88. Okay, so 2 packs of 2 or packs of 8 batteries. Okay, that's what you can get. So I'm going to write it down. Okay, packs of 2 or packs of 8 batteries. All right, you understand? Let's move on to question 15. Descartes buys 2 books for a total of $15. Okay, each book costs a multiple of $3. Okay, we don't know yet. And he purchased 1 book and 2 books. When he add them together, it was what? $15. Okay, and then each book cost a multiple of 3, which means what? It can be possible 3, 6, 9, 12, 15. Can't be because he bought 2 books, right? And here also 3, 6, 9, 12. Those are the multiples of 3, and when you add 2 numbers together, it has to be what? $16. And how much could each book cost? So when you add 2 numbers, okay, you have to make $15. So I just model it here. Let's say book 1, book 2. Okay, so let's see if the book 1 was $3. The book 2 has to be what? $12, right? Okay, what about 6 one? If the book 1 is $6, the book 2 has to be $9. You got it? So it has to be what? $3 and $12. Okay, it's gonna repeat again. So $9, $6, $12, $3. So we don't have to write over again. Okay, $3 and $12 and $6 and $9. Oops. Okay, you understand? So this is the possibility. Okay, Newton buys some boxes of dog treats for $9 each. Okay, some boxes. We don't know how many boxes. Okay, Descartes buys some bags of cat treats for $6 each. Okay, Newton and Descartes spend the same amount of money on treats. What is the least amount of money they could have spent? This type of question they are asking us because you know what? They want to expose you to the fractions. Okay? So I know when you hear about fraction, you're so excited, right? Like me, you're so excited. Wow, finally fraction, yes. Okay, so we are going to find out later more when you're learning about fraction. I'm gonna remind you. Oh, you do remember that factoring thing when we did? Yes. So this is the least amount of money we are gonna find. Okay. Uh, we call it least common multiple. Okay, least common multiple. Okay. Okay, we are going to find out later when we are learning fraction. But anyway, let's list them. The Newton buys what? Multiples of 9. Okay, so we don't know how many boxes, so we have to write down the multiples of 9, which is what? We know this. 9, 8, 7, 6, 5. Okay, let's wait in here to see, least amount of money, okay, they could have spent because they spent same amount. Okay, what about 6? Descartes spends the multiples of 6 because he purchased some bags of cat treats, which is what? Price $6 each. So now 6, 12, 18. Oh, hold on, I stopped. 9, 2, 3, 4. Already answer is here. So multiples of 6. What is the least common amount? Same amount, which is what? $18. I don't have to do more, but if you want to, it's gonna be 24. Come down, okay? But the least amount they spent together is what? Yes, $18. Okay, that's it for today. Your homework is what? Yes, 277 and 278. Do it at home, okay? I will see you guys next time. Bye bye.